2.1, that's going to be positive over a positive, which is positive. So it's also infinity. So we could say our answer was infinity, or since that's technically not a limit, you could also say that does not exist. This is kind of like the worst case scenario of these problems. Usually stuff cancels and they work out kind of like the other ones. So for once, I worked out the hard problem and gave you all the easier ones. Good. Okay, so when you have something like a fraction within a fraction, you need to make it into one fraction and then plug stuff in and see what happens. Okay, this one, if I plug in 2, which is where we start, even though it says 2 from the right-hand side, if I plug in 2 and it works, I don't have to worry about that right-hand side. But it doesn't, of course. So it ends up being 12. Right?
Couldn't we just do the bottom first and then see it's over 0 and then...
As long as the top isn't over 0 too. Is it? It's not, but...
So if it's like 1 or something over 0, then we can say...
You know it's going to be infinity. Okay. I just got to figure out if it's positive or negative.
So only if it's 0 over 0?
That's when you have to do some factoring or do some stuff like this. Good question. He said only if it's 0 over 0, in case you at home were wondering what was said. Okay, so on top, that's 12 plus 14 is 26 plus 2, I think it's 28. And even if it's not, really doesn't matter. The fact is that it's over 0. So I know it's going to be infinity, but I just don't know if it's positive or negative. So it's 2 from the right-hand side. So I'm putting in something like 2.1. So we just got to look and see if that's going to give us positives or negatives. On top, that definitely gives me a positive. Because everything's positive there. What about on bottom?
Positive.
Positive, because 2.1 squared I know is bigger than 4. So that's a positive over a positive, so that means your answer is positive infinity. Which does not exist would also work. But chances are, if it was a multiple choice question, it would say infinity. Same thing here. Plug in 3. I get 11 over 0. So I know it's going to be some kind of infinity because it's over 0. This time I'm plugging in 3.1. So positive or negative infinity?
Positive.
Positive. Now, let me warn you. I should have noticed this on the examples I was picking, but just because that's positive does not mean it'll be positive infinity. It does happen to turn out this way on these 3 examples, but that really has nothing to do with it. It's just whatever is down here that's making it positive or negative infinity. Okay, so this one is limit as x approaches 3 from the left-hand side, so that's like 2.9. Something slightly smaller than 3. On top, it's still positive. And on bottom, it is negative. So it's negative infinity. Okay, so that finishes up that stuff. And we're going to move on to the properties of limits which the blank notes are on Google Classroom. Properties of limits. This is the last section. We are going to have a quiz on Friday. It says it up there. You'll be able to use your notes in your homework. So just be prepared for that. Good. All right. Okay, so we're going to talk about some properties of limits. And up at the top, these things are important. We're defining some things. You take the limit as x approaches a of f of x. That's L. We're going to just call it L. And when you take the limit as x approaches a of g of x, we're going to call that M. So we're going to change all these so that's in terms of L and M. Basically, we're learning what limits, how we can rewrite limits, what we can do with limits and what we can't. So if you're taking the limit of two functions that are added together, then it is okay, it does work if you, it's kind of like distribute. If you take the limit of each part, and add them together. So then, according to what's up here, the limit as x approaches a of f of x, that's the purple one, that's L. So whatever the answer is there. And then the green one is M, so that's just whatever those two limits are added together. Same thing's going to work with subtraction. Limit as x approaches a of f of x minus the limit as x approaches a of g of x. So that would be L minus M. What do you suppose is going to happen with division?
L divided by M.
Yep. You can divide each one of them individually. So it's a limit as x approaches a of f of x over the limit as x approaches a of g of x. Notice you're not taking the functions first and dividing them. You're taking the limit of each one and then dividing them. There's a difference. Multiplication, same thing. There are going to be some curveballs here, just so you know. Have to have a curveball. It would be no fun. So this one is L times M. Now we're going to skip down to number 7. I don't like the order I put these in. So, I'm going to go to 7, then we'll come back up to 5. Okay, C stands for a constant. So you're taking the limit as x approaches a of a constant. So a constant can be any number, any real number.